So as I mentioned to you in the message there yesterday, uh, I'm going to be publishing all of the material for this module on this website. So this is similar to how I think Roseanne would have presented her web app dev to you last semester. I used Moodle predominantly last semester, but I'm going to use this website approach for this module. And we do use Moodle, all right, just for assignment submissions. So as we work our way through this module, there'll be new cards added pretty much each week, really. Some weeks a card might contain, or some cards might contain 2 weeks lectures. We'll just see how it works out. The recordings for each of the lectures will always be behind this card here. So I'm just going to give you an overview of the module first. That'll be pretty brief, really. And then we'll start into the first topic, if you like, which is the TypeScript language. So if I go into this card, and I'm just going to quickly run through this set of slides. As usual, I'll just pause maybe for a second in case there are any opening questions that any of you might have for me in terms of the whole module startup. No? Okay. So the first thing we'll notice really is I'm using the AWS logo on my opening slide, and that's intentional because we'll pretty much spend all of our time throughout this module, bar maybe the first 2 weeks. We're going to spend all of our time using the AWS platform, Amazon Web Services. Because when you talk about distributed systems today, we're invariably talking about cloud-based systems. And there are a number of cloud providers out there, as you know, but AWS is the dominant one and has been for a number of years and will probably continue for a number of years going forward as well. This module on the right, it's linked to two modules. It has stronger links with one than the other, and I'm trying to reflect that by the kind of thickness of the arrow here. So what I'm trying to get across here is that distributed systems has got very strong links with automated cloud services, which is a module that you would have studied in third year. And it has links as well with the web app dev module 2 that you did in the previous semester, in that we will be kind of revisiting the web API side of web app dev 2, but we'll be implementing a web API on top of the AWS platform. But the stronger link is with this module here, automated cloud services. This sentence here is not a complete sentence. I literally took that straight out of the module specification. And there's kind of two things that we can get from this sentence. One is a reference to architecture of distributed systems, in particular, kind of I'm calling modern distributed systems, and modern distributed systems is really a byword for cloud-based systems. So we are going to be looking at architecture, which tends to be a more theoretical subject, although this module is far from theoretical. The other thing I'm highlighting in this sentence is the area of design and deployment of distributed systems, of modern distributed systems or cloud-based systems. So it's very much kind of a skills base is what I'm focusing on the second part of this sentence. And as you can probably gather now from the way I certainly approached the Agile module last semester, I'm kind of big into giving students skills that they can actually demonstrate and apply. So this is going to be very much a skills-based module as well. But we will look at architecture, which tends to be more theoretical. And on the skills side, we'll be looking at the area of deployment, deploying a distributed application, in particular onto the AWS platform. Now, distributed systems can be very complex, so we don't want to get bogged down in the complexity of these systems. So that's what when I'm talking here about a constrained set of requirements. We'll obviously look at applications functionality as being quite restricted, but that's fine because our focus is not so much on functionality, it's more on the deployment of these distributed systems onto the AWS platform. Here then I'm mentioning some kind of themes that we will come across during this module. There'll be a lot of talk about infrastructure as code. Not sure if the infrastructure as code was mentioned to you in the automated cloud services. I'm pretty sure it was, but it wouldn't have been a major part, but it is going to be a major part of this one. And I will explain what infrastructure as code is when we come to talk about it, which we won't now until about week 3, I'd say maybe. So I'll just kind of leave it to, I mean, it's okay, it's code that we're going to be writing, but the purpose of the code is not to implement functionality or behavior. It's all about actually creating infrastructure up on the cloud. No more about it than that, I'll say for now anyway. The next theme is serverless, which is a philosophy behind how you deploy your or what kind of infrastructure do you use to host your distributed applications. So we're going to be focusing on a serverless infrastructure. And so I'll need to explain what do I mean by serverless, and then we'll have examples of deploying a distributed application onto a serverless platform, in particular AWS's serverless provisions. Yeah, I'm sure you may have come across the reference to serverless in any kind of readings that you might have done beforehand, but that's we'll cover it formally. Scalability is always an important characteristic of any distributed application. How well does your application scale up when the usage when there are spikes in the usage of the application? Because typically for distributed applications, it's going to be accessed by a large user base globally, potentially. And that user base usage there can be spikes in the usage profile. So does your application scale up, and is it able to handle those spikes? Or does it certainly grind to a halt when there's spikes in usage? And we don't like that, obviously. We'd like our application to scale as the usage profile changes. So in the sentence here, I mentioned architecture. We actually won't talk about architecture until the kind of latter end of this module. And there are two kind of dominant architectures when we're talking about distributed applications today. And again, you may have heard of these terms yourselves, either read about them yourselves, or they may have been mentioned in other modules in your preceding semesters. So there's this microservices architecture, which I'll talk about a little bit. And there's a more modern architecture is what's referred to as the event-driven architecture, which I'll also explain from a theoretical point of view, but we'll try hopefully and get an opportunity to implement some event-driven architectures, again, for a very constrained set of requirements, but you'll get an idea, hopefully, of what we mean by event-driven architectures. So there are some of the themes and that I hope to cover throughout this module. There's a lot of implementation, and there's a lot of coding in this module, and I've decided to use TypeScript as my language. I could have used any number of languages. I could have used JavaScript. I could have used Python, Java, C#, Go. I've just kind of arbitrarily decided to use TypeScript, A, because it's extremely unpopular, B, because it's very closely linked to JavaScript, and JavaScript is very familiar to you now after all the stuff that you did last semester. So hopefully the jump from JavaScript to TypeScript should be fairly straightforward for you. But I will do a kind of a crash course on TypeScript at the very beginning of this module. It's the first topic we'll look at. In terms of prerequisites, we're going to be using the AWS platform, as I said. So you're going to have to have your own personal AWS account. Now, it's possible in that automated cloud services module that you would have studied in third year. I think it was probably with Richard Frisby. It's possible that you did not have to create your own personal AWS account for that module. I think Richard may have used what's it called, the AWS Academy to create special accounts for you. Uh, those special accounts, those AWS Academy accounts, they won't work though for what we want to do. They don't have enough privileges. So you are going to have to create your own AWS account. And yes, that does mean you have to provide a credit card. And yes, that does mean you could incur costs. But the nature of what we are going to be using the AWS platform for, the costs are going to be minimal. We have to keep an eye on it though. We have to make sure that we don't let stuff running on the AWS in our AWS account unnecessarily. Essentially, anytime you're not working on on this module, you can destroy any resources that you might have created up on the AWS platform. You only need to have those resources when you're actually doing some work, whether that be in the lab or preparation for an assignment or doing your own self-study. And you'll see later on when I get into talking about infrastructure as code, how easy it will be for us to create resources up on the AWS platform and to destroy them. It'll just literally be one command. But for now, what I'm saying is you need to go away and create an AWS account for yourself. And so if any of you haven't used AWS for your personal accounts, that simply means going to this website here and just signing up. So I'm not going to step you through that. You need to do that yourselves. I've given you the web address there and where to go to. The second thing that you need to do is you need to install the AWS CLI on your local desktop machine. Now, you may already have the CLI installed from that other module, that other cloud-based module. If not, then you do need to install the CLI, and I'm giving you the web address of where to go to install it. And this web address explains how to do it for Mac, Windows, and Linux. So it'll cover every possibility. So again, I'm asking you to do that yourselves. I won't be stepping you through that in the labs. It's very well documented on this web page. So that's fine. The rest then is pretty much everything that you would have had from last year. So you will need Node running locally. Version 18 is the version that I'm using, 1.8. I'm sure version 19, the most recent version, stable version is version 20. So that's probably fine for what we want as well. But just to let you know, I think the version that you have from last semester should be still fine, provided it's version 18 or upwards from that. VS Code, fine. Git, fine. Knowledge of JavaScript is fine, even though we won't be using JavaScript directly. We will indirectly. And once you've installed the CLI, how do you know whether it's worked or not, whether the installation has worked or not? Then just simply type this command from the command line, and it should come back with some version. I don't really care what specific version of the CLI that you have installed, as long as it's version 2 dot something. You can see here I've got 2.2. I should probably upgrade it myself, really. But as long as it's version 2 dot something, version 1.x is too old for us. Right, that's that. When we're using the AWS there is a web interface called the Management Console, which I'm would have been used a lot in the automated cloud services. We will be using it a little. Well, we'll be using it quite a bit, I suppose, in fairness, but more to check that there are certain things, certain resources deployed correctly for us. So maybe you should re-familiarize yourselves with the AWS console a little bit. But as I say, as I walk through this module, you'll see me using it quite a lot during the lectures. So hopefully that will refresh your memory as well. But it wouldn't be any harm just to maybe remind yourselves of the AWS console and how you can navigate around the various services. Just some of the housekeeping side of things, 2 lectures per week, as you probably know, they're going to be all online. 2-hour labs per week. I'm not sure whether I think the labs, the way we ran them last year, that being kind of remotely, I think that worked okay for us. Maybe this week I could meet you in the lab and then we'll see how things work from there on. But remote labs will work fine for me anyway, whether it's okay for you or not. We can make a decision maybe a little bit later on. And if we do decide to have the labs remote based, then every now and again, if you need to, you prefer just to meet me face to face to discuss some particular topic every now and again, then I'm happy to do that. But maybe just for this week, we can actually meet up in the allocated room, and then we'll take it from there. It's 100% CA module. There will be some lab work, but you can breathe a sigh of relief. It won't be every single week submitting labs. That was a little bit intense for the Agile module. I think there are 3 labs that you will need to submit throughout the 12 weeks. And they will be worked. Have I mentioned it there? I haven't given percentages actually. I think the labs will probably be worked 20%, and then 2 assignments each worked 40%. In terms of the resources, we're using the website, as I've said. We'll be using Moodle for assignments, and I'll be using the Slack channel that I used with you last semester. And I mentioned this in the email yesterday anyway. Now, that's really, I think, yeah, that's all I want to cover by way of an overview. So it's very brief, very general, no specifics, but that's okay. I'll just, again, pause maybe for a second in case there are any questions arising from what little I've said so far. No? Okay, let's see. Let's go back to the website. Okay, so this is my first topic. We're going to look at do a quick crash course on the TypeScript language. Homework here is every section now is going to have the exact same images. There'll be slides, there'll be homework, which is essentially our lab work. There'll be an archive, and I noticed there about a half an hour ago that this link doesn't work, which isn't great because if I click on it, that's what you get, and that's no good. So I'm going to have to, what lies behind this card is a zip, an archive, and I will upload the archive onto the Slack channel, and you can get it from there. There won't be archives for many of the other weeks, as it turns out. So the fact that this this kind of card doesn't work is not that much of a headache for me anyway. So let's work our way through these slides, and the way I'm covering the TypeScript language is very much showing you examples as we work our way through. So there aren't a whole lot of slides in this set of slides. I'm using the contents of this archive a lot, though, as I work my way through the slides, as you'll see. So I'll bring up those slides. And I'm going to stop sharing for 1 second. Now, can somebody just confirm that you can see the slides again?
Yeah, we can see.
Okay, good. Right, I'm beginning with what I'm calling a marketing slide. So there aren't very many marketing slides in my slide deck. So anyway, let's just some of the kind of lightweight stuff. So the language itself, TypeScript, it's an open source language and was developed by Microsoft. And it's been around for quite a while, although it's only within from about 2017 onwards that its popularity has pretty much rocketed up the kind of languages charts, so to speak. But it has been in kind of incubation for a couple of years before it really caught on in the industry. And the person whose name I'm not too sure about how you actually pronounce the person's name, Anders Hegsberg, I'm sure I'm getting that wrong, um, is the same individual that designed the C# language and also Turbo Pascal, but certainly C#, as you know, is an extremely popular language. So this individual obviously has an excellent track record in designing languages. And I'm saying in the second point here that TypeScript is based on, you remember ECMAScript from last year, last semester, sorry, last year as well. ECMAScript is, you remember, is the specification for the JavaScript language. So TypeScript was actually based on two particular versions of that ECMAScript specification, version 4 and version 6. Now, version 4 goes way back to the early noughties. So that's really a long time ago, but clearly there was a lot of good stuff in version 4, even though version 4, I think, was abandoned. It was never actually implemented. Version 6, you might remember, is essentially ES, often referred to as ES 2015. So there was a lot of practical stuff in ES6 that materialized in language at the end of the day. But anyway, so he based the TypeScript language on those two versions of the ECMAScript specification. And if you've read anything about TypeScript, you'll have kind of read this kind of sentence that TypeScript is a superset of JavaScript, which kind of means that uh, all JavaScript is TypeScript, but TypeScript has some additional aspects to it, as we'll see. But you could literally rename a JavaScript file to a TypeScript file and it'll still run, as TypeScript. The next point I'm making is that, oh yeah, well, okay, we kind of essentially still write JavaScript, but we augment it with some additional syntax. And the syntax came from ES6 and also came from ES4. Now, the part of ES4 that we see in TypeScript relates to the typing system. You see, as you know, JavaScript is a dynamically typed language. What does that mean? That means when you declare a variable and you assign a value to that variable, let's suppose we assign a string to a variable, on the very next line, you can assign a number to the exact same variable. So the type of the variable was dynamic in the JavaScript language. Essentially, it meant that a variable had no type, or it could be assigned any type. Now, there were great benefits to that, but there were also serious issues with it. And what ECMAScript 4 tried to do is to layer a type system on top of the previously dynamically typed language, but it never came to pass until TypeScript came along. So, and we'll see that a little bit later on. I'm saying here that TypeScript is compiled to regular JavaScript. You can't run, there's no run time for the TypeScript language. All TypeScript is a compile time language. And when you compile it, and the compiler checks for errors, obviously, as all compilers do, but when you compile it, what the compiler outputs is plain old vanilla JavaScript. And then you run that JavaScript on your JavaScript runtime environment, whether that be Node or in a browser or wherever. So TypeScript can run on any browser, just as JavaScript can, because TypeScript is JavaScript when it's compiled. It can run on any host and any operating system. Okay, so that's fine. You might remember Bernard Eich. Bernard Eich was the creator of the JavaScript language. And this is just one of many comments I'm sure he's made about TypeScript. What he really likes about the TypeScript is that it got type inferencing really kind of nailed that, if you like. And we'll see what I mean by type inferencing later on. It's a really, really nice aspect of the language. If type inferencing was not part of the TypeScript language, the language may not have caught on as well as it has. And it certainly would be slightly more tedious for the developer if they had to write TypeScript without type inferencing being available to them. Another person who I'm not that familiar with this person, but I'm sure he's well known in the JavaScript community. His comment is what impressed him the most, really, is what TypeScript doesn't do. It does not output type checking. Oh yeah, when you compile TypeScript and it generates JavaScript, in the TypeScript, you have, amongst other things, you specify the exact type of each variable that you use in your TypeScript. But when that gets compiled, that typing detail is lost in the JavaScript. It doesn't appear in the JavaScript at all. And that's intentional. And that's something that impressed this second individual about the TypeScript language, that it does compile down to regular JavaScript. Again, if it didn't, it probably wouldn't have caught on as a language. If there were some slight nuances in what it outputted and it wasn't exactly proper JavaScript, if you like, it may not have caught on because that would restrict its runtime environments. The TypeScript language itself was really, it was really targeting large applications, large code base, if you like. Because when you're writing large applications in JavaScript, there can be real headaches, and you don't experience those headaches until you run your application. You know, we've all at this stage gotten the undefined error when we try and run a piece of JavaScript. Cannot access property of undefined. I'm sure you've come across that error and you can remember that error, and it can be a real nightmare to try and debug. Well, and you tend to get those kind of errors in large code bases because essentially you kind of lose sight of the structure of objects that are being passed around the place. TypeScript actually catches pretty much all of those errors at compile time. Uh, this is a screenshot from the GitHub website, and they do a survey every year on the popularity of languages, essentially based on how many repositories are there for the various languages out there. And you can see actually from 2023, we look at it here, from 2020, during 2023, TypeScript moved from fourth place up to third place. So it's still growing in popularity. And if you follow this plot all the way back, like it only began really in 2017, I think. Where did I see? Let's see, can I follow it back? 2017, yeah. So in that very short period of time, it has really grown massively in popularity. And that's largely due to the fact that the most popular language is JavaScript. But what's happening now in the industry is that any new web-based projects are probably not really being written in JavaScript at all. They're all being written in TypeScript. And that's why the language has become so popular. So it's a good language to have on your CV. Right, let's get into some of the specifics. So first of all, if you create a file and you want to store some TypeScript code in it, the file extension is .ts. There are also .d.ts files, which you would have within your code base, and these are what are called declaration files. And it's in these declaration files is where you declare the various data types that are relevant to your application. And we'll see a little bit of that as we work our way through this module. The majority of our files will be source code though. Source code files are just .ts files. The .d.ts, they don't contain any runnable code. They just contain declarations of data types. Which kind of, and I'm elaborating a little bit on these declaration files here. So they provide type definitions, and they're separate from the source code. If you've done any C or C++ programming, these .d.ts files are similar to header files in those languages. Also, where these declaration files are used is in many third-party JavaScript libraries, like all of the huge array of JavaScript third-party libraries, open source libraries that are out there in the community. It would be a disaster if we couldn't use those third-party libraries within our TypeScript code. But we can. And what the creators of those third-party libraries have done is they have added these declaration files to their JavaScript libraries, and the declaration files contain definitions of the data types that you should use when you're trying to integrate TypeScript with JavaScript. And we probably see that in passing. So that move by the JavaScript community to augment their third-party libraries with TypeScript declaration files, that was a really clever move, because that, as I said, that now makes all of the existing well-tested JavaScript third-party libraries, they're all available to us in TypeScript. Also, these declaration files, these are heavily leveraged by any kind of tools like VS Code, because what you see is VS Code is continuously checking your source code as you're typing it, and pointing out potential problems, and you'll see that a little bit later on. Okay, so with TypeScript, which is essentially JavaScript, but it's augmented with a type system. By that we mean that we declare the data type of each variable. Oh yeah, sorry, just before I talk about that, every language has what we would refer to as its primitive data types, and the primitive data types of TypeScript are no different from most other languages. So it has a numbers primitive type, and it doesn't distinguish between integers and floats. It's just numbers. It has a Boolean data type, primitive type. It has a string data type, and there is no distinction between single and double quoted. It has the null value stroke type, and we have a sense of what that means. And it still has the undefined type from JavaScript. So if you declare a variable and you don't assign it a value, then it potentially has the undefined type. But that's still there, if you like. So that there is primitive types. Okay, I'm using the word object types here, but any kind of collection types that it has classes, of course, which it gets me as 6. It has modules, which are collections of classes and other constructs. It has interfaces in the object-oriented sense. It has literal types, which we'll see a little bit later on. It has typed arrays, which is a really nice thing. So unlike JavaScript, in a TypeScript array, you have to declare what are the types of the variables in your array, and they can only have one type. So it supports typed arrays. It also has the different types that are built into the language form a hierarchy. And at the very top of that hierarchy, there is a type called the any type, which is from its name kind of indicates that it could represent any type. So if you had a variable and you said its type was the any type, then essentially you're back in the JavaScript world. You're saying it could be assigned any possible type of value. Clearly, we try to avoid at all costs having variables whose type is the any type. But it is technically part of the language's type system hierarchy, if you like. And all the types, including the primitive types, they're all subordinate to this any type. Okay, I've mentioned that. So the any type is something that we'd like to avoid. Okay, so in the previous slide, I talked about the types that are built into the language, that being the primitive types, classes, what else did I say? Classes, modules, interfaces, the any type. There are one or two other types built into the language as well. But they are the main ones. After that, then, you can define your own types. And this is where things get a little bit more interesting for us. Now, I'm saying it's optional here in the sense that if you declare a variable and you don't tell the compiler what type the variable is, then it will determine the type from whatever you assign it to. So that's why I'm saying it's optional there, but I've put it in brackets because initially we'd like to be specific about the type. So the first main characteristic of the TypeScript language is that we statically type our variables, which is something we didn't do in JavaScript. And I'm saying here that it's a lightweight way to record the intended contract of a variable or a function. Clearly, when you state the type of a variable, you're saying something about the intent on as to how that variable is going to be used, as in what types of values could potentially be assigned to that variable during runtime. Types also apply to functions, which we'll see a little bit later on, in relation to the signature of a function. How do you actually syntactically, how do you state the type of a variable. Well, I'll give you an example here. It's called the postfix syntax. So here I'm just declaring a variable called me, and this is the type part of the variable declaration. So I'm saying that the variable's type is string, which means that we can only assign a string to that variable during runtime. And I'm initializing it to a string, so I'm being consistent. Now, if I flip over to VS Code, so I mentioned that there is this archive here, which I'll provide to you on Slack because this link doesn't work. But when you download that archive and unzip it and import it into VS Code, you get essentially this here. And I've got various little examples that I'm just going to step my way through. Right now. Okay, so we're going to work our way through here, and we'll start off with 00 basics, and there's an index.ts, sorry. Right, again, here I'm declaring a variable called myString. I'm saying its type is string, and I'm assigning it a string. That's fine. Here I'm declaring a variable and its type is number. Number and string, as we saw on the slides there, are two of the primitive types that come with the language, and I'm assigning it a numeric value. If I try to assign a string to that, okay, the compiler is actually complaining. It has underlined the variable. And when you're doing TypeScript development within VS Code, the tab that you should have open all the time is this problems tab. And if I click on that, it explains the error that it's complaining about in your code. And it's fairly obvious in this case, it's saying it type string is not assignable to type number. So, I'm trying to assign a string to a number and it doesn't like that clearly. So that's straight away, that's our first highlight of the TypeScript language. You in JavaScript, if you had a variable and you initialized it to a string, and on the next line you assigned a number to it, or vice versa, then you're not going to get any errors. And when you run it, there won't be any errors unless and until you start using the variable and you start using it as a string, whereas it contains a numeric value, or vice versa. So you don't actually discover these things until runtime. Whereas with TypeScript, you're warned about them straight away. No, it doesn't like that. That's exactly what I was illustrating on that line, so I don't need to elaborate on that. That's fine, I think. Let's go back to my slides. Oh yeah, go back here again, sorry. The other thing that's nice with TypeScript, and it's a consequence of the fact that we have to declare the exact type of a variable, is that we get a lot of assistance from the IDE at development time. So what I mean by that is, if let's see, oh yeah, if I unhighlight this line or uncomment it. So my number is a number, its type is number, and this doesn't make sense calling the uppercase method on a number type. doesn't make sense. And we're getting an error from the compiler. The compiler is always running kind of in the background, checking things. And it's telling us straight away, you cannot call this method on a numeric type. Now, again, in JavaScript, we wouldn't discover this error until we actually ran the code, because JavaScript, doesn't go checking at development time. It doesn't go checking what type is the variable on the left, and does this make sense in the context of the variable on the left, because the variable doesn't have a type. It's dynamically typed. So again, that's just another one of the small but significant advantages of the JavaScript language, is it catches silly mistakes that you might make as you're writing the code. It catches them before you actually run the code. So that's, again, as I said, that's a consequence of this typing system that's being applied, essentially being applied to JavaScript. Typed arrays, I mentioned them there a while back. All arrays have to be typed, and the syntax for that is like this. So my numbers are my nums, postfix, which is my colon symbol. I'm saying it's a number, and this here indicates that it's an array of numbers. So it's just the subscript symbols. And indeed, what's to the right is an array of numbers. And again, if I had one of these entries as a string or a Boolean or anything else, then the IDE is going to complain straight away, because it's saying on the left, you said that it's going to be an array of numbers, but you've got something other than a number in the array. We got examples. No, no, we don't. What's the error here? Oh yeah. Oh, that this is another, just to go back to this, the fact that the compiler catches things before you start running them. I've got the my Boolean has been declared up here as a Boolean variable, Boolean type variable. Where did I declare it? Do I have my Boolean? Oh yeah, there I've declared it as a Boolean type and initialized it to true. And then I'm trying to carry out an arithmetic operation on the Boolean. And clearly that doesn't make any sense. Although in JavaScript, this would potentially run okay, and it would produce a result. The result may not be a sensible result, but it will produce something. But clearly, it doesn't make sense to be adding something to a Boolean. And yet again, the compiler catches this at compile time before we ever get to run it. Okay, back to typed arrays though. I don't have an example of typed arrays, it looks like. Oh, I do here. Okay, that's the array. And again, like I was saying, if I try and put in a true here, Boolean value, it doesn't like it. Yeah, it's highlighting, and then we look at the error down here. And we realize we shouldn't do that. It's fairly obvious here, but if we were trying to push a value onto my array and push a Boolean onto this my nums array somewhere else in our code, that's when we try to do the push operation, and we pass the push method a Boolean value, that's when it will catch the error at compile time for us. There is another syntax for declaring an array of things, and it's this syntax here. Okay. So that's an alternative to using just the square brackets. Clearly the square brackets is much shorter to type, but I'm showing you this syntax here because it's something that we'll see a little bit later on. But for now, they both have the same effect. Essentially, we're saying it's an array of strings in this case. Let's see. Oh yeah, it's kind of the point. I'm making the points before I read the code. But again, if I uncomment this line, I'm getting an error because my nums has been declared as an array of numbers. Here I'm trying to push a string onto that array, and it complains. The compiler complains. So it kind of takes the type of the variable and it carries that with it all throughout your code. The fact that we're doing it here in the same file is a bit silly, but if we had other files and we were passing our mynums array around the place, its type would travel with it, so to speak. And again, if we were writing ordinary JavaScript, then we wouldn't realize, well, in fact, this would still work because the mynums would be just an array of things. It wouldn't be an array of numbers. Okay, that's typed arrays, and that's the syntax for them. I'm saying here as well that we can also apply this this typing syntax. We can apply it to functions as well, and must. It's not so much can, but we must apply it to functions. Here's a very simple example. I've got a function that takes 2 arguments, and here we're saying that the first argument, its type is number, and the second argument happens to be of type number as well. So we have to declare the signature of our functions as well. Now, for now, I'm leaving out the return type, but that becomes important as well. But we'll talk about that a little bit later on. So that's what we call type annotations. We're annotating each variable with some additional information and specifically typing information, type-related information. For now, we're just using primitive types, but in a while, we'll use custom types as well. And finally, the last point is that we need to use these type annotations on our function parameters as well. TypeScript has classes, but we're all very familiar with classes from other programming languages. And on the right, I'm just showing you an example of TypeScript's class syntax, which is essentially taken directly from ES6 JavaScript. So I don't need to explain the syntax on the right there. You're all very familiar with the notion of classes. And TypeScript supports single inheritance. So here we have an example of an animal class, and we have a snake class that extends animal, and we know what that means. So it's just straightforward inheritance, but it's single inheritance. Am I right about that? Oh yeah, it's single inheritance is what the language supports. And we have the notion of public and private members of a class. So you can declare certain methods as being private or public, and you can declare instance variables as being private or public as well. And we should have a good sense of what that actually means without me having to get into explanations of it. We have interfaces. Again, it's something that you would be familiar with from other languages, and they work the exact same in TypeScript as they do in other languages. And on the right, again, I'm showing you the actual syntax for it. So I'm declaring an interface there on the right called drivable, and drivable has 2 methods associated with it. And then further on in the code, I have 2 classes that implement that interface. And we know what the consequence of a class implementing an interface is. It has to implement the methods defined in the interface. So I don't need to show you examples of that or explain them. So that's interfaces kind of in the behavior sense. Now, The language also has, not sure why they didn't give us a different name, it also has interface data types, and these are very important part of the language. So what's an interface data type? I'm saying an interface data type tells the TypeScript compiler about the property names and of an object and the values of those properties. So we're talking about objects here in the data sense. We know that JavaScript objects are essentially an encapsulation of some an object contains a number of properties where each property represents some data value. And a collection of properties within an object is a way of encapsulating or kind of a wrapper, if you like. But with interface data types, what this allows us to do is to state what are the valid properties of a particular object if it says that this object has a particular type associated with it, and what are the types of values that those properties can have. So we're essentially applying typing to our data objects. So here's an example. Here's how we declare, looks very like behavior interfaces in fairness. So I'm declaring a type here, a data type called person. And I'm saying a person object has two properties, first and last, and both of them are of type string. And then down here, I'm declaring a variable whose type is person. And I'm honoring that type because here I'm saying that the me object has two properties, first and last, and I'm assigning strings to both of those. So yet again, if I declared in me, if I left out the last property in this declaration, the compiler will complain. Or if I assign something other than strings to first and last, the compiler will complain. Or if I add another property to the me object that's not in the interface, the compiler will complain. So it's tying us down. These data interface types constrain how we can actually construct objects of that type for good reason. And I probably have examples of that in the archive. Yeah, that's the exact same example. There we go. And like I said, if I try to do something here, like I go address, you can see straight away it's complaining. And if we look at the error down here, it's saying that the type does not include address within it, which it doesn't. Let's see what else. Oh yeah, what I'm trying to get across from this line here is that, again, this is one of the benefits of the TypeScript language. It kind of helps you as you're writing your code. So when I go me here, dot, like it's telling me, look, these are the only two options that you can have after the dot. And that, something as simple as that has been a source of a lot of headaches for JavaScript programmers. Because in JavaScript, if I accidentally type, let's say, first name here instead of first, then I won't discover that me.first name results in undefined until I actually run the code. But I never get to that stage because in TypeScript, because it's constraining me straight away. You can only use one of these values after the dot. So again, one of the nice things about the language, it helps you as you're coding. Now, consequence, whereas in JavaScript, objects can have properties added to them dynamically. You cannot do that in TypeScript. So this line here doesn't work. I can't certainly go me.address equals that because again, I'm not respecting the structure of the person interface data type. So that's one of the downsides of TypeScript, if you like, that objects are not dynamic in terms of the properties that they can have. That doesn't work. And these interface types then, you get some more examples here because they are more flexible than you think. So here I'm declaring a student interface data type with properties name, ID, and modules. And modules, you can see here, is actually an array of strings. So it doesn't have to be all primitives. I can have more complex interface data types. And moving on, I have student X, and so this would be a valid student type. Again, it's honoring the structure of the interface. I've got a results interface data type, and it seems to comprise of a module name and grades. And grades is a number array. That's fine. Just another example. I've got a student profile interface data type. And what's interesting about this one is one of the properties, its type, is something that's not a primitive. It's a custom type. Yeah. And so here's an example of an instance of a student profile object. And again, the compiler will check that everything matches up here. That name can only have properties first and last because that's what a person type was declared as earlier on. And this here, its type is result. It's a results array. Result was declared here as being of this consists of a string and a number. And you can see my array here are indeed arrays of objects of the correct shape, if you like. And I've commented one out here, but if I uncomment this one, because that's not a valid result. My result interface type, its two properties were module name and grades. And here I've just used name as a property, and that doesn't match up. So the compiler will spot that at development time and tell you about it. And again, these are the types of mistakes that we kind of make when we're writing JavaScript. Because if we've got a lot of different structures within our code base, then we just can't remember the names of the various properties of all of those structures. But the compiler here is helping us essentially. If I just scroll back, is something I just overlooked. As well as the primitive types. Where do I mention it? Or do I mention it? I mentioned it there. Oh yeah, as well as the primitive types, there are some other useful types built into the TypeScript language. One of them is the regular, sorry, where do I mention regular expressions? Oh yeah, one is the regular expression type. Again, that's just built into the language, if you like. It's not a custom type. And we've all come across regular expressions at some stage along the line. And I'm just demonstrating the use of regular expressions here. And you can look at that code yourselves later on. But it's a built-in type. So that is interface data types, a really important part of the language. And just a small thing to note that there's no equals sign here. It's just and I'm mentioning that for a reason because you'll see a little bit later on. Could be actually the next slide. All right. The next aspect of the TypeScript language are what are called type aliases. And when you read about type aliases, initially you think to yourself, well, aren't type aliases the exact same as interface data types, and you'd be right. So you have a choice of whether you want to use a type alias to define a structure or an interface data type to define a structure. And it's either or. You can use either or to define the structure. But type aliases have other use cases as well, which we won't talk about in detail now, but it's these other use cases that we tend to use type aliases for, rather than using them just to define the structure of an object, if you like. So I'm saying here that type aliases, that they're creating a new name for a type, and that's essentially what interface data types do. Interface data types allow you to declare new types for your application, like person type, student type, result type. Aliases allow you to do the exact same thing. So straight away, again, as I say, that kind of indicates that they're covering the same ground. So type aliases are similar to interface data types, but in addition, the but part here is the extra bit. In addition, you can declare what are called union types and tuples, which we won't really use, and literal types. So it has a broader application, these type aliases. In the screenshot, I'm showing you some examples. And if we look at the third part, the third example, really, I probably should have ordered these slightly differently. But if we look at the third example of the usage of this type alias syntax, this is the example. In this example now, the third one, is the exact same as a type, as an interface data type. So I'm declaring a type called point, and I'm saying a point is a structure that has an X property and a Y property. X has to be a number and Y has to be a number. Now, as I said, too many times probably already at this stage, we could use the interface data type to declare the point type just as well. Slight difference in the syntax. There is an equal symbol here, whereas in interface data types, there is no equal symbol. So that might be a tiny little typing mistake that you might make when you're using type aliases and interface data types. But essentially, this is a new type, but it's the exact same as how we might declare an interface data types. Up here, then I've got other examples of using these type aliases, and here we're also declaring new types, but the types that we're declaring, we could not use interface data types to declare those. So take the first one. I'm declaring a type called alphanumeric, and what this is saying is that any variable of type alphanumeric, it could be a string or it could be a number. And there are cases when you will need that. Here I'm declaring an actual variable, and its type is alphanumeric, and I'm assigning it, in this case, I'm assigning it a numeric value. And the compiler won't complain. If I had another variable whose type was also alphanumeric, I could assign it a string, and the compiler won't complain, because that's what I've said alphanumeric types are. So alphanumeric is a custom type that I've defined for myself. Here's another example of using type aliases, and this is something that I won't go into detail now, but I'm actually declaring a type here called pet category. And I'm saying pet category, it can only have this value or this value or this value. Note here, I'm declaring a type. I'm not declaring a variable. So I'm declaring a type called that, and I'm saying any variable of this type, the only values it can have are cat, the string cat, the string dog, or the string goldfish. And on the next line, I'm actually declaring a variable. I'm saying its type is pet category, and I'm assigning it the string dog, so the compiler won't complain. If I assign any other type of string other than these three, then the compiler will complain straight away. So this is a little bit like an enumerated type, if you're familiar with enumeration. The language here is something that you need to kind of get used to. We're talking about declaring types and declaring variables. in this line here, on line 11, I'm declaring a type. On line 12, I'm declaring a variable that can hold an actual value. On line 13, I'm declaring a type. Sorry, on line 13, I'm declaring a variable. Beg your pardon. I'm declaring a variable. And so it can have a value. Don't worry about the underlines here. The underlines is just a VS Code thing, which is telling me you declared this variable, but you're not using it. So this is not a compiler error. On line 15, I'm declaring a type. On line 16, I'm declaring a variable. Here, I'm also declaring a type. And what am I doing here? Here, I'm declaring a variable. So type aliases, for now anyway, type aliases and interface data types kind of look like they're covering the same ground, but there are additional things that you can do with type aliases. Not sure if I have examples of type aliases in my archive. Let's see, all interfaces, just to labor the point, if I change this to type, and I do an equals over here, then, look, I don't have any errors in my code. Everything is still fine from a compilation point of view. So that just reinforces the point I've been making, that type interfaces, sorry, interface data types and type aliases do overlap to a degree. Okay, here's some type aliases. Type course. So this is a standard kind of usage of the type aliases. I've got type course, consists of properties title, code, and qualification. That's fine. All right, here I've got another type alias called academic entity. And I'm saying an academic entity is either a student type or a course type. Student is one of the interface data types that I declared earlier on in this script. Course is the one that I've just defined up here. Okay, so I've got an academic entity type defined for myself using the type alias syntax. Here I'm declaring an actual variable. The variable name is entity, its type is that. And for this particular instance, it looks like I'm assigning a student. Student X is a variable that I declared earlier on. I go back to it. There's student X there. Where were we? Let's see. No, type aliases. Okay, so entity that's fine. And I think I just leave it at that really for now anyway. Okay, I've just introduced a function here, and the function is called that, and it takes a variable, it takes a parameter, sorry, takes a parameter of type academic entity. And clearly then, well, I suppose inside in this function, because one of the parameters that it's passed in, because that parameter could have one of two possible types, then more than likely, we've no idea as to what this function is doing, but more than likely within the body of the function, you do need to probably determine, well, was the academic entity parameter that was passed in to me, was it a student type or a course type? And that might determine the processing that goes on inside here. And the way I'm determining it is I'm saying, does entity have a property called code in it? And if it does, then based on the fact that course is the only of the two courses, the only one that has a property of type code, sorry, a property named code, then the processing that I would do inside here would relate to a course parameter. Whereas here, I'm more likely processing a student parameter. So you will need to, when you've got these type aliases that can represent, a number of possible data types, and you do need to narrow it down. I'm getting a little bit ahead of myself, though, in this example here, but I'm just raising the point anyway. Okay, and I'm calling it, okay, so I can call this with a student X, and I can also call that function. And here looks like I'm passing it an actual course. And we're going to do more on these type aliases a little bit later on because they are quite powerful. Okay, it's type aliases for now anyway. Come back to them though. Moving on, type inferencing. So, and this was one of the sweet spots, according to Bernard Ike, of the TypeScript language. The fact that what type inferencing means is that the compiler can infer the type of a variable for you rather than you being explicit about declaring the type of a variable. The compiler can actually infer or deduce what type a variable is based on how you initialize it. And what that will mean is that we don't have to physically type as much code as we would have to if type inferencing wasn't part of the language. Now, there's a lot of usage of the word type there in that explanation, but if I just read the sentence, I guess it says TypeScript compilers can infer the type of a variable based on the values that that variable gets. And so the screenshot shows an example here. So here I'm declaring a variable called num, and let's see, what am I trying to get across from here now? This, I know, just give me 1 second. Oh, okay, I'll step my way through it. So alphanumeric is a type I'm saying can be string or number. I'm declaring a variable num here. Its type is alphanumeric and I'm assigning it 10. That's fine. I'm declaring a variable called string. Its type is alphanumeric. I'm assigning that string. That's fine. Category. I'm just wondering, is this the wrong? Oh, sorry. Sorry. I think I hit back arrow in my PowerPoint slide and I didn't realize I hit back arrow. So it didn't make any sense to me. Okay, let's start again. Type inferencing. The TS compiler can infer the type of a variable based on the values that that variable gets. Okay. Take two. So I'm declaring a variable called a string. And note, I'm not actually stating its type here at all. I'm not using that postfix syntax. And I'm assigning a string to this variable. Now, the compiler will infer from this statement that the type of this variable is a string type. And you can actually, I suppose if I go back to here, a little bit easier, if I go right back to the start of this example of this script. So if I take out this here, so I removed my explicit declaration of the type of the variable, the compiler will actually work it out. And if on the keyboard now, what I'm doing is I'm typing the command sequence, Command K, Command I. So when I do Command K, Command I, the compiler is telling me the type of this variable is string. It has inferred that from the value that I've assigned to it. And that means that I really didn't need to be explicit about the type of this variable when I was actually typing up the code. Equally, I can take out this and it will infer that the type of this variable is number. And it'll carry that typing information with the variable everywhere you use it. So that means that we don't have to physically type as much syntax when we're writing our TypeScript code due to type inferencing. Now, when you start programming in TypeScript, it's probably a good idea to be explicit about the type of a variable and use that postfix syntax. But as you get more and more experienced, you realize I don't actually have to physically type or assign explicitly a type to each variable. I let the compiler infer the type for me. And that type inferencing really means that you, as a developer, your productivity is greatly increased because you don't have to physically type as much code as you would have to if type inferencing wasn't supported by the language. So that keyboard sequence, Command K, Command I, that can be very useful to us when we're writing TypeScript code, because as our application gets larger and larger and we're passing variables around the place, and maybe we've forgotten when I declared this variable, what did I actually declare its type to be? Then just hit the keyboard sequence Command K, Command I, and the compiler will tell you what type the variable is. Okay, what's the second example showing me? Oh yeah, well that type inferencing, it's actually uh, it's much more powerful than the little simple illustration that I've given you there. If you take this example here, right? So I'm declaring a variable called friends, and it's an array of person objects. And here I'm initializing it. That's fine. Okay, I'm being explicit here about the type. That's fine. And then down here, I'm invoking the filter method on friends. You'll remember filter from last semester. So what the filter method does, you remember, is it takes this array and it selects particular elements within the array and it puts those elements into this output array. But notice here, I'm not stating what type this output array is, this sFriends array. I'm not stating what type it is, but the compiler will actually infer the correct type for me. It will infer that its type is an array of person objects. Because what it has done is it knows this is an array of person objects. It knows that filter takes certain entries in this array and puts it into this array. So if this is an array of person objects, then this must also be an array of person objects. It infers that. Equally, it infers that this here, this parameter, its type is a person object. So that's really where type inferencing starts to get its power. We kind of realize is much greater than this simple little example up here. I have some examples of type inferencing going on. Interfaces, let's see. Type aliases. Okay, type inferencing. Fine. Okay, so a string is a string. It has inferred that it's a string type. The char at method takes this string and returns a kind of a subset of it, beginning at it's looking for the character at position 2. But because this is a string and because it knows about the char at method, it knows that the char_add method returns a string. And so if I do Command K, Command I on this, it's telling me that its type is, where is it telling me? Oh yeah, its type is string. Similarly, on this line here, the length property of a string is a numeric value. And so len here, I haven't been explicit about what type it is, but the compiler will infer that its type is, sorry, I need to get rid of that there. Command K, Command I, it infers that it's a number type. This is the example I think I had on the slides. I have my array of friends here, and I'm calling the filter. And so this must be Command K, Command I. Yeah, it's a person array. It's infer that. The map method, you remember, it maps over this array. Now the thing about map is map also produces an output array, but the elements in that output array is dictated by the callback, you remember? Now in my callback, it looks like I'm putting into the output array just the first property of each friend. First, you remember, is, sorry, the first property of each person, and first, you remember, is a string property. So that must mean that this should be an array of strings. Will the compiler infer that? Let's see. Yeah, looks like it's got it right. It's an array of strings. Now, as I said, as a beginner, you might, when you're typing this code here, you might be explicit about this. You might go, string array, and that's fine. You're doing some extra typing though. I wonder though if we said this is a person array. And it doesn't like that. And again, if we look at the error down here, if you read the detail of the error, it's saying that a string array is not assignable to a person array because it knows that the output of the map is an array of strings, and you cannot assign an array of strings to a person array. I don't know what, sorry, that was a completion done by there. It's the same error though. Yeah. Oh, sorry, yeah, that's the cannot find name person. Sorry, now where did I get that from? Let's go. Okay, person is defined in another file. Let's see if I go number. If I go student, I had student in this file. Yeah, type string array is not assignable to type student array. Right, so in really, you try and let the compiler infer in most cases. Let it do the work. And unless you start getting errors down here, then you may have to be explicit about the typing information. But otherwise, the advice is let the compiler do the inferencing for you. After a while, I think maybe initially be explicit about the types. So that's type inferencing, a really powerful part of the language, and one of the reasons why the language has become so popular. Otherwise, it would be a bit of a pain, really, if we had to be explicit about all this typing syntax. I don't think I need to worry about that part for today. All right, back to my slides. Let's type inferencing. Let's talk a little bit about functions. I've already said that you have to declare the type of a function in the sense that you have to be explicit about its signature. Signature of a function is the parameters and the return type of the function. And so in my example here, I've got a function called add numbers, and it takes two parameters, it looks like, both of type number. And it's this part over here. This is where we declare the type of the return value for this function. We need to do that as well. Now, in many cases, the compiler can infer it, but if you have to be explicit, this is the syntax that you use. There are a couple of syntaxes, as it turns out, but this is the one that we'll concentrate on for now. So that's looks like it makes sense, because if we look at what the function is returning, it's adding two numbers, so that means it's computing a number and returning that number, and that's consistent with the return type that we're stating here. And yes, indeed, the compiler can often infer the return type. So in the example here, I've got the add numbers array function. It takes an array of numbers, it looks like, and it takes a single number, and it looks like it maps over the array of numbers and produces, there's a computation on each one. So if you follow the logic of what's going on here, that this thing here, new nums, its type will be an array of numbers, and that's what I'm returning. And when I do Command K, Command I on my function, it has actually worked out that the return type, where is it telling me that now? Sorry. Oh yeah, it's worked out that the return type is a numbers array. Okay, it has inferred that. I was not explicit about the return type here. Now, I've got a separate file that has various examples of some function-related examples. So, yeah, add numbers, section number. Let's see, add numbers. Sorry, which one am I looking at? No, this is the one I want to look at. I guess as we're at it, really, you see here I have an import statement, and I'm importing a file called my types. And here's a file called my types, and you can see its extension is .d.ts. And this is the first example of these declaration files that I mentioned. And if I look inside the declaration file, all it contains, all a declaration file contains is declarations of data types that apply in your application. And I have, in this case anyway, I have an interface data type for friend type, and I'm exporting it. And I've got a interface data type for person as well. And I've got some other ones in there as well. And we import that in the normal way. So it looks like I'm just importing person, which presumably I use later on in my code. Back to functions though, basic function typing. So we've already seen something similar to this example here. And here's another example. Is that the same one that we had? Add numbers. Oh yeah, when in this example, I'm not stating the return type here at all. But if I do Command K, Command I, it has worked out that the return type for this function is number, and it has inferred that based on looking at the actual code in the function and looked at, followed the logic, even though there's only one line of code in this function, but it would follow the logic through your code, or probably work backwards from the return statement to find out what are the types that of the variables being used in the return statement, and then infer the return type of the function from that. Before I talk about higher order functions, sorry, go back here again to this. We know that arrow functions are a big part of modern day JavaScript, and they're also obviously an important part of TypeScript. So here I've got an example of an arrow function. So I've got the add strings. Oh yeah, I just want to show you the syntax, I guess, the TypeScript syntax, fairly predictable maybe, but here is where we're essentially declaring the signature of my arrow function. And then we've got the body of the function. Well, not a whole lot surprising going on there. Let's see the second example. In this example here, it's kind of a made up example, but actually, did I actually show you how to run a TypeScript? I don't think I have actually. Let's go back to basics index.ts. How do I actually run that code? Because I think it's got a few console logs in it. The command to run TypeScript is, and you'll find it in the README. This is the command here. You've got to run npm install first, obviously, because this is essentially a node project. You can see the package.json file here. And in package.json, we have some dependencies that are TypeScript related, dev dependencies. The TS node is a utility that will allow us to run our TypeScript code directly without having to compile it first. Essentially, what TS node does is it takes your TypeScript file, compiles it on the fly, and then runs it on the node platform. The alternative would be you'd have to compile it first yourself and then run the output of the compile as an ordinary node file. Here we're just importing the actual part of the language itself. Dependencies, we don't actually need that as it turns out. But you do need to run npm install in order to get these dev dependencies installed. And then running a TypeScript file, you use that command. So if I go npx, npx ts node, now I can be specific about the index.ts if I want to, but because it's index.ts, it will infer, well, not infer, but it will assume that it's the index.ts that you want to run. And okay, that's the output of the various console log statements that I had in this file. You can look at that later on yourselves. So that's how you run a TypeScript file. As I said, alternatively, you can, it's a little bit trickier though, you can compile it first. So the command to compile, if we look at the README, tells me to compile it, you use this command here, npx tsc, and then the name of the file. So let's do that. What doesn't it like? Do I leave some errors in that file? I wonder. Oh yeah, okay. And if I look now inside the folder, you'll see here that there is an index.js. And if I open that up, it is regular JavaScript. So that is the JavaScript equivalent of my TypeScript file. And if you scan down through it, if you take that line there, there's no typing information included in the JavaScript because JavaScript doesn't have typing associated with its variables. So if you like, we lose all of that type-related information in our JavaScript. The TypeScript is very much a compile time language. The runtime language is plain old JavaScript. Now, to run this JavaScript file, we use just the node command. There is a bit of a gotcha though, because if I try and do that now, if I go node, and I want to run src index.js, I try and run it, I'm getting an error. And the way you fix the error, I don't want to get into the details of it though, but essentially the error is telling me that you've got, what is it telling me? Oh yeah, see here it's saying export is not defined in ES module scope. What does it mean by that? Where it's getting that from is in my package.json. This is all kind of stuff that you don't really need to know now, but in the package.json, I have said that here I'm saying I'm using ES6 type import statements in my JavaScript. But the JavaScript that's generated by the TS compiler uses what's called CommonJS type import export statements. So if I change this to CommonJS, and again, you may not be familiar with CommonJS, but if I just follow through, if I save that change and now try and run my JavaScript using Node, then it runs fine. So the TypeScript compiler generates JavaScript that uses the old type of import-export statements. Whereas I stated in my package.json that I will have modern import-export statements in my JavaScript. Now you might say, why not just leave it as CommonJS? Well, I think that actually causes problems then when I try and run it using TS Node. So it's either or really. So I have to keep it as module, which means modern import exports. You won't ever need to do an explicit compilation of your TypeScript anyway. We'll always be running our TypeScript using TS Node. but just to show you that in the background, or as a by the way. Right, so that's how you run TypeScript, which you seem to have overlooked. Should have done it earlier on. Back to functions, and let's see if I lost my train of thought now. Let's go back to the functions file. Oh yeah, I know now where it was at. So I was just discussing this function here, which is using the arrow syntax for declaring the function. And okay, I've shown you the how you declare the signature of that function. Other than that, okay, specifically what the function does is it takes a string, it looks for a particular set of subcharacters in that string, which I'm calling the axis of the string, and then it rotates the source string around that axis. Okay, that's just what it does, you know. Let's see. So if I, for example, if I run it and I invoke it twice here, I invoke it with that source string, as in here. Let's see, I'm invoking the rotate function with my source string, and I'm using, oh yeah, sorry, I see now where my second parameter here, axis, I'm saying it could be of type string or of type regular expression. Sorry, that's why I use this particular example. And just as an illustration, right? So a parameter, in this case anyway, the parameter could have one of two possible values. It could be a string or a regular expression. And then inside in the body of the function, I have to determine whether the axis parameter was invoked with a string or a regular expression. And that's what this statement is doing. This is just plain old JavaScript. The way you can check is I'm checking the type. Type of is an operator that has been available in the JavaScript language from day one. And it's unfortunate, it's called type of, but really all this operator can do is it can check to see, is it a primitive or an object or a function? It doesn't have any powers beyond that. Doesn't understand custom types, TypeScript custom types. So in this case, I'm just checking to see, is it an object? And if it is an object, then based on the logic of my parameter, that must mean it's a regular expression. And I do some processing based on the understanding that axis is a regular expression. The else then must be relates to the second possibility where axis is a string. Now, what point is it trying to make? The point I'm trying to make is if we do a command K, command I on axis here, let's do that. It has actually worked out that the type of axis here must be a regular expression. So the compiler has been clever enough to work that out based on the condition test that I do here. And I know I've written this condition test, and I know that that condition test, if that is true, then that means that axis is a regular expression. And the compiler has actually worked that out as well, though. Whereas down here on the else side, if I do command K, command I, it has worked out that axis inside in the else clause is a string. So I suppose I'm just trying to illustrate how powerful the compiler is at working out the type of a variable, even in this case when it has one of two possible types. That's really all I'm trying to get across there. Anyway, if it's a regular expression, then I do certain processing here. If it's a string, I do certain processing, and then I do my actual rotation of my string. You can look at the logic yourselves later on. I'm not interested in the specifics of the function. All I'm interested in are two things. A, how do I declare an arrow function in TypeScript? And that's essentially what's being illustrated here. And the second point of this example is the cleverness, I suppose, of the compiler in that it can work out the different possible types of this access variable based on the logic, the flow of logic in your function. I wouldn't worry too much about the second point, I suppose. It's more just the signature is all that's important for you guys at this stage. Where are we on time? Okay, we're up as it seems, it looks like. Right, just kind of hoping to get a little bit further than this, but so be it. That's fine. I'll leave it at that for today. Now, it really means that, well, I guess I'll talk to you about the lab on Friday. And what I will do as well, and remind me if I forget it, I will upload the archive that I've been looking at here. I'll upload that to Zip or to Slack because you can't access it from the website. All right, we'll leave it at that for now, and I'll talk to you on Friday. Thanks a lot.
Thank you.
Thank you.